Hello ladies and gentlemen, welcome back. This video tutorial is for students who are in Geometry Goal 5, and specifically we're going to be looking at more quadrilaterals. Quad meaning four, lateral meaning side. So quadrilateral means any four-sided shape. We took care of squares and rectangles pretty thoroughly in an earlier video, and now we're going to be doing the other types of quadrilaterals. So now that the fun stuff is starting to unlock, let's get started. First things first, parallelogram. I talked in an earlier video that we want to start getting used to the fact that area is no longer length times width, it is base times height, and this is where it's coming from, because your base is going to be effectively the bottom side, or if you have trouble finding it, it's the side that is connected to your right angle box. And then the height itself is the thing that actually, makes the right angle box. So parallelogram, parallel means you have two sets of parallel sides. So this side is parallel to this side is parallel to this side. Hopefully you remember that shape from middle school math. What do we have? Our base is, this is going to be the same as this, so it's going to be 11 times our height, which is 13, and the math for that is pitifully simple. It is going to be 143 inches squared. Again, there's the base. The 11 is a red herring. There's your height. So area is base times height. So it's going to be 12 times 10, which is 120 inches squared. So that's pretty straightforward. Now, what if you have something that's maybe not necessarily a parallelogram? Well, here we go. We have a triangle, trapezoid, and parallelogram on the coordinate plane. So give an exact answer means already that we're going to have some ugly decimals, but specifically not just ugly decimals. We'll find out as we get there. Simplify your answer as much as possible. So find the perimeter of the triangle with these vertices. So there's one, there's another, there's another. So let's see here. This is 2, 2. This is 2, -3. So since these line up, I can figure out a base. That's 2 from 3. So this is a this is a height of 5. And then this is going to be -4, -3. So this acts as a base. If I'm jumping from 2 to -4, I'm doing a jump of 6. So area is 1/2 base times height. So 1/2 5 times 6, which is going to be 15 units squared. There we go. Find the perimeter of the parallelogram. Okay, so let's get ourselves vaguely set up. That doesn't look perfectly like a parallelogram, but we can pretend. No, I can't. Ms. Dubois is paranoid. There we go. Okay, we have what? We have 5, 3, -1, 3. So we already know that the height is, no, that's a, all right, let me stop thinking I know what I'm doing until later. 5, 3, we have -1, 3, we have 2, -2, and -4, -2. I had to think about that. Goodness gracious me. All right, so first things first, we kind of need a height. So let's see here. Right angle box. Beep. So what's our height? We jump from 3 to -2, so that's a height of 5. The next question is, what is our absolute base, the bottom of our shape, the thing that is closest to the right angle? We go from 2 to -4, so that's 6. Now we have everything we need. Area is base times height, which is going to be 6 times 5, which is going to be 30 units squared. There we go. Okay, not so bad. I'm 90% sure this gives you an actual coordinate plane. If not, you can let me know in the comments. But even if you don't, I didn't, and I'm able to figure out how I'm getting what I need from here as necessary. Now, finding the area, and now they do give us a coordinate plane. And again, they give you just enough information so we can figure out what our base is going to be, and then we got to figure out what our height is. And so, let's simplify this out. We are jumping from -9 to -5, so that's a height of 4. We're jumping from -4 to 3. That's pretty far, but that's a jump of 7. So area is base times height, which is 4 times 7 times 7, which is 28 units squared. Next up, what is our base going to be here to here? Let's see here. I jump from -9 to -5. That's a jump of 4. Next, what's my jump from here to here? I jump from -3 to +6. That's a jump of 9. So base times height, 9 times 4, 36 units squared. So we're doing pretty good so far. Next up, area. Again, we're looking for a shaded piece, which means we're going to be doing some subtraction. So that means we need to find the area of our two different shapes. So it is the area of our rectangle minus the area of our triangle, which is going to be a base times height minus a 1/2 base times height. So what's the base and the height of our rectangle? 9 and 7. So 9 times 7 minus 1/2, what's our base? 6. What's our height? 4. 9 times 6 is 54. Let's see here. 1/2 times 6 times 4 is 12. So 54 minus 12 is 42 yards squared. Okay, that actually wasn't that bad. Here it's a little bit different. We have the area of our triangle, and we're subtracting an area of a rectangle. Okay, so what's the area of the triangle? That is 1/2 base times height minus a base times height. So for the triangle first, what's our base? They tried to piecemeal it again, but we're not going to let it confuse us because we know what to do. We have a 4 and a 4 and a 1. So that's 9 and 2 minus base times height, which is 4 times 2. So that is going to be 9 minus 8. So it is 1 feet squared. Okay, this actually doesn't look too bad. I'm getting pretty comfortable with this. Next up, finding the area of a trapezoid on a grid by using triangles and rectangles. So they're basically describing what you're doing here. You have the area of one shape, which is a rectangle. You can find the area of that. Then you can find the area of one of the triangles, and you can find the area of the other triangle. So we're just, think of it as a piecewise. We're basically doing this one piece at a time. So the area of a rectangle is 1, 2, 3, 4, 5 by 1, 2, 3, 4. That's a 5 by a 4. I'm going to write that a little bit darker so you can read it. 5 by 4 is 20. Triangle on the left, so that's 5 by 1, 2, 3. So this is a base of 3, and my height is 4. So 1/2, I'm going to write that down, 1/2 times 3 times 4 is going to be 6, I think. Yep, 6. And then the triangle on the right, so that's 1, 2, 3, 4. So that's 1/2 times 4 times 4, which is 8. And hey, what is 20 plus 6 plus 8? 34 units squared is the total area for the trapezoid. Same thing here, area of the rectangle, that is 2 by 3, which is going to be 6. Area of a triangle is 3 by 1, 2, 3, 4 by 4. So that's going to be 1/2 times 3 times 4, which is going to be 6. The total area is 6 plus 6, which is 12 units squared. So far, so good. Keep a little bit going. Now, area of a trapezoid, they're getting you used to where up here they do it by breaking down into shapes. Here, there is an actual kind of formula for it. So, area of a trapezoid, I'm going to draw a little baby trapezoid, is, let's see here, we have to take the average of the bases, multiply it by the height. So here's our first base, the 5. Here is our second base, which is the 11. So 5 plus 11 over 2, and then here's the height, which is the 7. You'll notice they will more than once try to give you a red herring. This is not the first time the software has done that. We're going to blatantly ignore it for the sham that it is, move on, and use only the numbers that we need. So 5 plus 11 is going to be 16 over 2 times 7. 16 over 2 is 8 times 7. So this is 56 centimeters squared. Let's see here. There's our first base. Oh, wait. Base 1 plus base 2. So average of the bases times the height. So there's the first base. There's the second base. So 14 plus 4 over 2. And then there's the height. So times 5. 14 plus 4 is 18 over 2 times 5. which is going to be 9 times 5, which is 45 yards squared. So this right here is the new formula that they're trying to get you used to. Average of the bases times the height. Average of the bases times the height. I'll actually give you a couple of seconds to write that down. Okay, now, rhombus, same idea, base times height, and now they give it to you a little bit differently. So PR, so from here to here to here, that is going to be 18, and then QS is going to be here to here to here, Miss Dubois, darken it up, and that is going to be 30. Find the area of the rhombus. Be sure to include the correct unit in your answer. Now, where they had a unique formula for a trapezoid, they also have a unique formula for a rhombus. You'll notice that they didn't give you anything that looks like a base or a height, or they didn't even give you a side. What they did is they gave you something called a diagonal. So diagonal being from one corner to the next. I assume that's obvious, but just in case. What you're going to do, so the area of, I'll do a little diamond for a rhombus, that is your 2 diagonals over 2. That's the formula. So they gave us the 2 diagonals, so that is 18 times 30 over 2, which is 270 meters squared. Yes, I did that in my head. You shouldn't even be surprised by now. Next up, we have, let me see, FH, which is the first one I highlighted. Is it the first one they gave us? No, it's 26, though. And then GE is the other one they gave us, and that is specifically 16. So the area of a rhombus is diagonal 1 times diagonal 2 over 2. So that is going to be 16 times 26 over 2. That's a little bit big for me. That's going to be 16 times 13. Let's see what that is. 16 times 13 is 208. I wasn't even close. So that's going to be 208 millimeters squared. So again, this is the new formula. I'll give you a couple of seconds to write it down. Okay, now that you have it, and now that we have our formulas, there's the last topic in the list. Let's see here. Now we have a trapezoid, a rhombus, or a kite in the coordinate plane. So now we're kind of using all of our skills in one fell swoop. We can see at a glance that this is going to be a trapezoid. They even tell us a trapezoid, so that's B1 plus B2 over 2 times H. So what are our 2 bases? We go from -2 to 2, so that's 4. Then we go from -7 to 7. That's a big jump. That's 14 over 2. And what's our height? We go from -6 to -3, so that's 3. 14, that's 18 over 2 times 3, which is going to be 9 times 3, which is 27 units squared. And then we need our diagonals. So here's one diagonal, because this is a rhombus, so it's diagonal 1 times diagonal 2 all over 2. And then there's my other diagonal. So what's this one? I go from 6 to -4. That's a big jump. That's a jump of 10. And from here, I'm going from -6 to 8. Ooh, that's an even bigger jump. That's 14. So 10 times 14 all over 2. It is going to be 70 units squared. And see, now we're starting to get into all of the fun stuff because we had all of our interesting little new shapes and a couple new formulas to write down and use as a reference. Ask the upperclassmen teacher, but I can talk. Ask the upperclassmen teachers if you are allowed to have a formula card with you when you're taking your DSA, because there are, that's 3 formulas anyway, 4 if you include, squares and rectangles and all of the other more standard stuff. So ask if you're allowed to have a formula card for your DSA, because I don't teach upperclassmen. I don't know how that works, but keep that in mind. As always, that's it for now. Next topic or next video will be significantly shorter. And as always, stay happy, stay healthy, stay safe. I'll see you in the next one.